Welcome to Study Loop.
Problem 70. In this problem, we have been given a circuit containing a capacitor and 3 resistors. In part A, we have to find current through R1, R2 and R3, that is I1, I2. This is current through R2 and I3, and this is current through R3. While in part B, we have to find the total charge on capacitor, that is QC, is equal to unknown when switch is closed and it has been some time. For part A, we have to analyze this circuit as we see that here is a node, we call it node A, and voltage on it is given, supposed to be VA. Now we can say that if I1 is current through resistance 1 or R1, it will equal to current through R2 and R3, that is the current through R1 is equal to the current through R3 and R2 at node A as shown in the figure, and we see that I1 is equal to source voltage minus VA, that is voltage on node A, divided by R1, that is resistance 1, and I2 is equal to VA, that is voltage on node A, divided by R2, and similarly I3 is equal to VA over R3. So we put all these values into the equation, that is we call it equation 1, so that equation 1 implies that source voltage minus VA over R1 is equal to VA over R2 plus VA over R3. Put in values, we get source voltage is 42 volts minus VA, it is unknown, divided by R1, and it is 8 ohms, and it is equal to VA over R2, and R2 is given as 6 ohms plus VA over R3, and R3 is equal to 3 ohms. So simplifying for VA, we get 42 minus VA equal to 4 VA, and VA is equal to consequently 42 over 5 and this results in VA of 8.4 volts. Now I1 will be equal to 42 minus VA, that is 8.4 volts divided by R1, and R1 is 8 ohms, such that I1 is equal to 4.2 amperes. So this is our answer to I1. And for I2 we have I2 is equal to VA over R2, and it is equal to 8.4 divided by R2 is equal to 6 ohms, and this results in I2 of 1.4 amperes. So this is our I2, and for I3 we have I3 is equal to VA over R3, and this equals to 8.4 sorry 8.4 divided by R3, and R3 is equal to 3 ohms, and this results in I3 of 2.8 amperes. So this is the value of I3, that is current through resistance 3. Now for part B we have to find in part B we have to find QC, that is total charge on capacitor. QC will be equal to C into VC, that is capacitance of the capacitor and voltage on the capacitor. And when the switch is closed and after a long time the capacitor passes no current, and it behaves like an insulator such that no current flows through it, and all current passes through R1 and R2, and the R3 is also open, so that total voltage is equal to, that is equal to I into R1 plus IR2, and I is equal to source voltage divided by R1 plus R2, such that I is equal to 42 over R1 plus R2, that is 8 plus 6 and this results in total current of 3 amperes, and Vc will be equal to V2, that is voltage of resistor 2, and voltage of resistor 2 will be equal to IR2, and this equals to V2 of 3 into R2, that is 6 ohms, and V2 is equal to 18 volts. We have to add another sheet such that now Vc will be equal to V2 sorry, and Uc is equal to Vc multiply C, that is capacitance of the capacitor, and we get 18 into the capacitance of the capacitor is given as 4 microfarad, that is 10 to the minus 6, and this equals to 72 multiply 10 to the power minus 6 coulombs, or 7.2 multiply 10 to the power minus 5 coulombs. So this is the charge that is accumulated at the capacitor after a long time when capacitor is fully charged. And this is end to our problem. Thank you for watching.